The fate of the planets is intricately tied with that of the star that they orbit. So for our own solar system, the sun dictates our fate.
As our sun has changed, so has the potential for life on our neighboring planets. Their history shows that habitability is a delicate balance. That doesn't always last. There is only one planet that has retained its water and habitability, and that's Earth.
What's remarkable about Earth is the stability of those conditions, that Earth has been able to maintain oceanic conditions at its surface throughout its entire history, through billions of years, and that's what's facilitated the very rich biological evolution of Earth.
Earth is a very special place. It's the only place in the universe where we know definitively that there is life.
For that to happen, you need not just liquid water appearing on a planet, but liquid water staying on a planet, and that's the magic of Earth.
Thanks to the size and geology of our planet, the atmosphere has remained stable enough for billions of years, protecting the precious water that has enabled complex life to evolve. Life has woven itself into the fabric of the planet. And has shaped the continents and the oceans. So that now, life itself maintains the very atmosphere that protects our fragile ecosystems. But as the sun continues to grow hotter, temperatures on Earth rise. Upsetting weather patterns, raising great storms across the planet, and devastating droughts. As plants around the world die out, oxygen levels plummet. Around 1 billion years from now, the age of complex life on Earth will finally draw to a close.
Earth will ultimately be like Venus and Mars, just mostly CO2. There'll be nothing else really in the atmosphere. And it will remain in that state as a sort of hot oven planet until ultimately the sun, when it uses up its hydrogen and goes into a different phase, will become what we call a red giant.
You know, as we've seen in other stars throughout our galaxy, throughout the universe, our sun will continue to get hotter and hotter over time.
And at that point, it will expand greatly to the point where it will nearly engulf the Earth entirely. And at that point, the planets will lose their atmospheres and they'll be just sort of swept away.
As it exhausts its hydrogen fuel, the sun's outer edge inflates. As our star enters its red giant phase, expanding millions of kilometers out into space. Mercury is the first to be engulfed. Then Venus's fate is sealed. Some models predict that Earth may barely escape the fiery fate of its neighbors, hanging on beyond the edge of the dying star with Mars. But the long era of the 4 terrestrial planets will be over. The lives lived on one of them, nothing more than a distant memory.
Poor Uranus. It's got rather boring clouds, truth be told. So there wasn't a lot to see with the cameras.
Passing close to the planet, Voyager's sensors reveal why Uranus is so featureless. Temperatures here are the coldest of any world in the solar system. There's simply not enough heat to drive the storms seen on Jupiter and Saturn. Uranus is an entirely new class of planet. An ice giant. And more surprises were to come. Uranus has rings.
We knew long ago from telescopic observations the rings were there at Uranus. We didn't know their configuration or their shape.
Voyager begins to explore the ring system and spots something curious in the shadows. Two moons, Cordelia on the inner edge of the brightest ring, and Ophelia on the outer edge, help to organize the system.
Particles within the rings can be moved inwards or outwards as these tiny objects called shepherd moons, whose gravitational force can shape and sculpt the rings themselves.
But it's the orientation of the orbits of these moons and the rings themselves that singles out Uranus as the strangest of worlds.
Uranus looks bizarre. The rings, rather than looking like that when you look through a telescope, they're actually orbiting up and over the top of the planet. The whole thing is tipped like a spinning top.
This bizarre orientation hints at an unusual past. Since the beginning, everything in the solar system has been circling in the same direction. It begins with a vast cloud of material that orbits the young sun. Over time, the material draws together, forming each of the planets. Today, they all orbit the sun and spin on their axes in the same counterclockwise direction as that primordial cloud. Except for Venus and Uranus, which spin in the opposite direction. But Uranus is even stranger, because the entire planet is on its side.
This was a really strange system. So why is Uranus so tipped on its side?
If a roughly Earth-sized object smashed into Uranus late in its formation history, then that would have had the proper amount of momentum to basically knock it on its side.
And the collision may also help to explain another of Uranus's mysteries: why the planet is so cold.
That impact presumably relinquished all of that internal energy that the planet had when it first formed, and has left it as a relatively dead and sluggish world.
Much is learned during this brief encounter. But Voyager's strangest discoveries are yet to come. What powers weather is very different depending on where you find yourself in the solar system.
The Earth's atmosphere and the weather on Earth is driven largely by one thing, and that's the sun. And the sun pours its energy down through the atmosphere, and it hits the surface, and the surface of the Earth then warms up.
With Earth, you've got all the energy coming in from the sun, heating up the surface, creating thermals that then drive the atmospheric flows that we see. Somewhere like Saturn doesn't have a surface to be heated up. So when you compare the weather systems on these giant planets to those that we have on Earth, you have to sort of tear up the rule book a little bit.
The sun is the great controller of Earth's atmosphere. But in the outer reaches of the solar system where Saturn lives, sunlight is 100 times weaker. It means some other heat source must be driving Saturn's incredible weather. As Cassini studied the cloud tops of Saturn, it was able to infer a huge amount about the truly strange world that must lie beneath, and the energy source that helps power this planet.
We had a whole variety of scientific goals at Saturn, and one of the main ones was to understand the meteorology of the Saturn atmosphere and what energizes the winds that we see on it and so on. And we have affirmed now the belief that atmospheric systems on Saturn are actually powered by energy from below, from an internal heat source on Saturn. They're not powered by sunlight like we have on the Earth.
Looking deep inside the planet reveals a heat source shaped by extreme pressure. Within huge clouds of water, Cassini records lightning 10,000 times more powerful than any on Earth. This lightning transforms methane gas into enormous clouds of soot. At 8,000 kilometers deep, the pressure of the atmosphere is 80 times greater than that at the bottom of our deepest oceans. Enough to transform this graphite rain into diamonds. But even these diamonds are likely destroyed by the pressures of Saturn, eventually dissolving. "30,000 kilometers down, and Saturn's heat source is revealed. Here, pressures are so intense that the atmosphere behaves like a liquid metal, able to conduct electricity. In this state, molten helium falls like rain. And as it merges with the surrounding material, kinetic energy is released as incredible amounts of heat. And it's this extraordinary heat source that helps drive Saturn's weather. Sent to look for conditions where life could have begun is NASA's Mars Reconnaissance Orbiter. MRO sends back more data than all other Mars missions combined.
MRO has 3 cameras on board. The first is the Marcy weather camera. It sees horizon to horizon on every orbit. So it builds up a map of the entire planet every day, so you can see a global weather map every day on Mars. The second camera is the context camera. It provides high resolution, and it's covered about 99% of the surface.
MRO has made more than 60,000 orbits. Its high-resolution cameras revealing Mars in unprecedented detail, discovering polar avalanches, shifting sand dunes, and what look like seasonal flows of sand or even liquid meltwater. Then, in 2017, MRO turns its gaze to one of the red planet's oldest features, the Eridania Basin, thought to have been an ancient sea.
Eridania Basin is a huge basin in some of the most ancient crust on Mars. It formed about 3.8 billion years ago, and it held more water than 10 times that of the Great Lakes, or 3 times that of the Caspian Sea on Earth.
And it is on the ancient seabed that MRO sees something remarkable.
MRO saw a massive 400-meter-thick deposit formed from a mineral that forms in deep-sea hydrothermal environments, such as one that might have undersea vents.
Mars not only had the same ingredients for life as Earth, it also had an active environment to spark it into action.
Eridania Basin was an ancient sea 3.7 to 3.8 billion years ago, and that's about the same time when life was first emerging on Earth. This might have been a place where life could have existed, because those hydrothermal vents underneath that sea might have created a very conducive environment for life.
These initial conditions in the history of both planets look so similar that it seems reasonable to expect that this could eventually lead to life.
These actively fertile conditions are thought to survive in places like the Eridania Basin for hundreds of millions of years. But then, 3.7 billion years ago, something happens that transforms prospects for life on Mars forever.
Mars underwent a fairly substantial transformation in its climate. The climate got colder. What liquid water there was either soaked into the ground and froze or froze at the surface. A lot of it ultimately would get transported to the poles, where it forms these big, thick ice caps that we see today.
At the same time as the temperature plummets, Mars becomes more volcanically active, leading to catastrophic flooding. Water rages down from the southern highlands until, in a place known as Ekis Chasma, it plunges over cliffs 4 kilometers high. Creating the largest waterfall the solar system has ever seen. Cascading into a spectacular canyon 10 kilometers wide by 100 kilometers long. Once the floods subside, the water disappears. The only trace it ever existed etched into the planet's surface. Neptune. An ice giant, 17 times the mass of Earth. Over 1.5 billion kilometers farther from the Sun than Uranus, Neptune is almost chemically identical. Yet bizarrely, it couldn't be more different.
Neptune, in a way, was almost a relief because it wasn't featureless. You know, it's like, oh, good, a planet with clouds and features again.
Neptune was a great excitement. It's got swirling clouds, really strong winds. At 1,500 miles an hour, incredibly fast, the fastest winds that we've got in the solar system.
One of the things that Voyager discovered was an immense dark vortex within the atmosphere. A huge, swirling dark spot.
We say it's a giant storm, but just those words don't fully contain, we're talking about a storm the size of the planet Earth or larger.
And the surprises keep coming. Even though it's much farther out, Voyager discovers Neptune is warmer than Uranus. And the source of the heat is another oddity of this strange planet.
In fact, when we look at this dynamic activity in these extraordinarily cold regions, we really are at a loss to understand just what's going on here.
One theory is that the buildup of pressure beneath the thick layers of cloud turns the carbon and the methane into a rain made of diamonds. They then melt as they fall into the interior of the planet, producing the extra heat. As the heat makes its way out into the frozen cold of space, it churns the entire atmosphere, whipping up winds around the globe.
There are no mountain ranges, no valleys, no continental boundaries to get in the way of the perfect fluid dynamical flows. What that means is that when you start a weather pattern going, when you start a vortex spinning or you start a plume rising, there's very little to get in the way of it.
So those winds that develop and go around, they just keep going around and around. There's nothing to slow them down, no friction with the surface.
And the extreme cold here makes the atmosphere less viscous. Creating supersonic winds that outpace anything seen on Jupiter or Saturn. Most surprising is Mercury. The least explored of the rocky planets, because of the difficulty of getting into orbit around a planet so close to the Sun.
5, 4, 3, main engine start, 2, 1, and 0, and liftoff of Messenger on NASA's mission to Mercury. A planetary enigma in our inner solar system. Now going through the sound barrier.
Following a direct route to Mercury would be impractical. A spacecraft would arrive at such high velocity, it would need to haul a prohibitive amount of heavy fuel in order to slow down enough.
We just had spacecraft separation.
Grounded solids have jettisoned.
So Messenger controls its speed by stepping from one planet to the next, using their gravity to slow itself. Even so, Messenger still approaches Mercury moving so fast that it is forced to fly past the planet 3 times, slowing on each pass. Until after nearly 7 years of flawless navigation, it arrives safely in orbit. At last able to begin its mission, mapping Mercury's surface.
That first image ever acquired from orbit around Mercury was amazing. When it finally came in, it looked perfect. It looked exactly like we expected it to be. For me, that was the real moment when I realized that we had successfully made it into orbit and everything was working.
This pioneering voyage has led to a completely new idea of how Mercury may have formed. Mercury is the most cratered planet in the solar system, with many puzzling features that hint at a violent past.
Mercury has a very unusual orbit. If you were on the surface of the planet, you would actually have to go around the sun twice to get one full Mercury solar day.
Also highly unusual is the planet's disproportionately large core.
Mercury is basically a big ball of metal surrounded like a tiny bit of rock.
How do you end up with a planet that has so much metal inside and then almost none on its surface? That was a huge mystery.
And the major question is, why? Why is it like this when the rest of the planets aren't?
A clue to understanding these strange features was found in Mercury's chemistry.
So very soon after we got into orbit, we started to get chemical data back from the surface, and we immediately got some surprises.
The tiny probe detects volatile chemical elements in concentrations that no one had thought possible this close to the sun.
These are elements that go into rocks, but that evaporate at relatively low temperatures. And immediately told us that some of the older ideas of how Mercury formed could not be correct.
What Messenger discovered about Mercury could suggest a new twist in the story of the solar system. Just a few million years after its formation, the young Mercury is seething with the heat of its violent birth. Slowly, a crust forms, rich with volatile elements. If it had been close to the sun, these elements would have evaporated before the rock hardened. So what could explain why they're so abundant on Mercury today?
The orbits of the planets and their current locations have changed over the history of the solar system. So where things are today doesn't mean that's necessarily where they formed. They could have and probably did move from different locations to where they are now.
One possible thing is that Mercury didn't form where it is today. It formed much closer to the other planets, maybe even outside of Venus or Earth, or somewhere in between there.
If Mercury had formed near Earth and remained at a more comfortable distance from the sun, its destiny could have been very different. But it wasn't to be. So what turned it into the strange, sun-scorched world we see today?
We don't know the full story. What we have right now are theories, and as we have new observations, we are trying to change everything to fit those observations.
Messenger's evidence of the volatiles on Mercury's surface and the unusual size of its core suggest an interesting new theory. It's possible Mercury began life as much as 160 million kilometers further from the sun than it is today. In the region of space where the young Earth is also forming. A region with scores of planetary embryos all fighting for position. In the chaos, it's possible that something large pushes Mercury off orbit and in towards the sun. Mercury brushes against another planetary embryo. This glancing blow removing much of its crust and mantle. Now little more than a metallic planetary core. Mercury continues toward the Sun. Ending up in the peculiar elliptical orbit we see today.
Before we sent the Messenger mission to Mercury, I think we had a very simplistic idea of what it was going to be like. And Mercury turns out to be a more complex place with a more interesting and complex history than we had previously imagined.
But of course, all things have to come to an end, and once we were out of fuel, we could no longer burn our engines to keep from crashing into Mercury.
And sequencers, chief launch detector on. Engines running yours, continue on.
After 4 years of observations, Messenger's fuel finally runs out. And the spacecraft adds yet another crater to this tiny world, where any prospects for life were scorched away when it was thrown too close to the Sun. The Sun's outer corona burns at a scorching 1 million degrees, releasing a barrage of charged particles that travel at around 400 kilometers per second. The solar wind. This onslaught would strip away our atmosphere, but for the powerful force that protects us, the Earth's magnetic field.
Solar wind is this stream of charged particles that come streaming out from the sun. And at Earth, which has a powerful magnetic field, when those charged particles begin to get close to Earth, they get diverted around Earth by interactions with that magnetic field.
That protection keeps solar wind and other ionizing radiation off of the surface. So on Earth, where we have this really great magnetic field, we are nice, safe, and sound inside the shell of that, protected from all that radiation.
The magnetic field of Earth effectively forms a protective bubble around the Earth's atmosphere.
And when the sun dips below the horizon, there are times when Earth's protective force field is visible. The aurora is a stunning display of Earth's magnetic field in action. It's best seen at the poles, but across Earth, it's protecting our atmosphere and all life on our planet. This vital protective shield is generated deep within.
The way a magnetic field is generated inside a planet is when you have convective motion in a fluid that is capable of conducting electricity. And in the Earth, that electrically conducting fluid is liquid iron. And the molten portion of the Earth's core is a place where these motions take place, and it can set up a magnetic field.
Just like Earth, Mars once had a molten metallic core, generating a magnetic field around the planet. Auroras danced above Mars's poles, protecting its atmosphere and seas below. But the field didn't last.
In the oldest rocks on Mars, you see evidence of a once powerful magnetic field. You get to the younger rocks, the rocks that are 3 billion, 2 billion, 1 billion years old, no evidence of a magnetic field whatsoever, and there is no intrinsic magnetic field on Mars today.
500 million years after it formed, Mars's magnetic field dies out. The bright auroras above its poles slowly fade away as the shield that protects the planet shuts down for good.
Once it stops, then what happens is all the atmospheric components, things like hydrogen and oxygen that make up water, they get stripped away because you don't have the shield, the magnetic shield anymore, so the high energy particles that come in from the sun and from outer space, they begin to strip away the components that make up water.
Without its magnetic field to protect it, Mars's atmosphere and then water slip away into space. So why did Mars lose its protective shield? What happened deep beneath its surface that stopped Mars from developing like Earth? The answer lies at the beginning of Mars's story, at its very creation. $4.6 billion years ago, when the planets were forming from the dust clouds circling the sun, early differences between Mars and Earth set the young planets on very different paths. Mars forms further from the sun, where crucially, there is less rocky material to build a planet.
Mars is different because it's not just further out, it's actually much smaller. If a planet gets to be too small, it just freezes all the way through.
Mars is just half the diameter of Earth, meaning its core cooled more quickly. And so it lost the heat that powered the dynamo that generated its protective shield. Mars's small size, condemning the planet to die. Millions of years ago, Saturn has an extra moon. Perhaps 400 kilometers across, and formed almost entirely of ice. But this moon is doomed. It's orbiting just too close to resist the immense forces of Saturn's gravity.
The rings probably formed from an object that got too close to Saturn. There's this invisible boundary around Saturn called the Roche limit, and that's the limit, depending on what you're made of, where Saturn's gravity is strong enough it will actually pull you apart, that the gravity on the side closer to Saturn is strong enough that compared to the gravity on the other side that will literally rip you apart. You don't have enough gravity of your own to stay together.
A leading theory suggests that just beyond Saturn's atmosphere, an ice moon approaches close to or even just inside its Roche limit. As Saturn's immense gravitational force pulls it apart, the moon begins to rupture catastrophically. A world ripped apart by its proximity to a giant. Up to 17,000 trillion tons of ice breaks apart in orbit around Saturn. And thanks to the speeds this material is traveling, it's likely that in just a few days, it spreads out to encircle the great giant. Saturn's iconic ring is now in place. But as Cassini turns its instruments towards it, it sees a single ring, transformed.
The images we returned, they were phenomenal. They were resolution a factor of maybe 20 times better than anything we had had before.
Cassini reveals how Saturn's giant rings have evolved. This debris now forms a disk wider than Jupiter, yet on average, just 10 meters thick. Within, moon-sized chunks of ice orbit the structure, clearing great voids, turning one ring into many. But it's as Cassini captures images with the sun directly above the equator that the most surprising feature of the rings emerges.
We knew this was going to be a time for us to investigate the third dimension, something that you don't get to see when you just look at a picture of Saturn's rings. And what we found was staggering. Just right out of the gate, we saw vertical structures. I just can't tell you how surprised we were to see this. It's just the spectacle of it was just unanticipated. I have just imagined flying along in a shuttlecraft across the ring, right, close to the ring. So to my perspective, it would be almost like it was an infinite sheet of gleaming debris. And I'm flying along and flying along and flying along, and suddenly I come upon a wall of rubble that's 2 miles high. I mean, is that cool or what? Really, I've said over and over again, they should put that in a movie.
This once tiny world of rock and ice that has seen the most dramatic transformations is today the solar system's greatest jewel. After more than a decade in orbit, Cassini has forever deepened our understanding of Saturn. But its mission is far from over. As the young Jupiter circles the sun, it clears a path through the gas cloud that envelops the early solar system. But that process causes it to do something alarming. Jupiter begins to spiral inwards, plowing straight through the region of space that would become the asteroid belt.
When the young Jupiter moves through the primordial asteroid belt, things get scattered around, things get gravitationally deflected, and as a consequence of all of this gravitational interaction, more than 99% of the original mass that was there is basically now gone.
The asteroid belt has been disrupted over time by the movement of the giant planets. And this has acted to throw material from the asteroid belt out of the asteroid belt into the outer solar system.
These protoplanetary cores, like Ceres, were never able to graduate to full-fledged planets because there was just not enough material in the orbital neighborhood.
When Jupiter passed through the primordial asteroid belt, it starved Ceres of material, halting its growth. And the dwarf planet was condemned to live out its life as a cold, barren rock. But Ceres isn't the only world in our solar system whose development was cut short. Mars would suffer a similar fate at the hands of Jupiter. After marauding through what would become the asteroid belt, Jupiter enters the region of space where Mars is forming. Continuing its journey, spiraling towards the sun. As Jupiter bulldozes inwards, its immense gravity scatters material in all directions. Some is sent careering into the sun. And some is thrown out into interstellar space.
It is because of the gravitational clearing of this neighborhood by Jupiter that Mars was unable to grow to more than 10% of that of the Earth. This is why Mars is small.
And by clearing material out of the inner solar system, the giant planet may also have prevented the formation of the super-Earths we see in other systems. And if it had continued moving inward, our planet too might never have formed. But then, just as it looks like Jupiter will sweep everything away, the giant planet stops in its tracks. Because in the shadows of the outer solar system, another planet is forming. The solar system's second gas giant, Saturn. And its arrival changes everything.
As Jupiter moved inwards, Saturn moved inwards and caught up to Jupiter's orbit. When this happened, the two locked into a special configuration known as a mean motion resonance. This is where the planets begin to interact gravitationally in a very coherent manner. And now, locked as a unit, the two reversed their migration course and moved back out.
Saturn caused Jupiter to retreat. Leaving behind just enough material from which the inner planets could form. Mercury, Venus, and our home.
Earth is in exactly the right location to provide the environment for life to develop. So if Jupiter had moved around even more, who knows? Maybe life never would have developed in the solar system as we know it.
And as its voyage across the solar system draws to a close, Jupiter helps to provide our living world with its most precious ingredient. Today, 2/3 of our planet's surface is covered by ocean. More than 1.3 billion cubic kilometers of water. Each drop teeming with life.
One of the big questions about the evolution of our solar system is, how did we get water here on this planet?
So we think that the inner planets didn't naturally form with a lot of water. Water is primarily in the outer solar system. But if you end up having Jupiter and Saturn moving outwards, then that is able to suddenly deliver more water into the inner solar system.
Locked in a gravitational dance with Saturn, Jupiter moves back through the asteroid belt. And as it does so, water-rich material is flung inward, where it is incorporated into the growing terrestrial worlds.
So the movement of the giant planets have actually played an important role in the delivery of water to the inner solar system.
In a sense, it is Jupiter's outwards motion through the asteroid belt that we have to thank for the delivery of water to the surface of the Earth. The Earth would be quite a different planet if not for Jupiter's primordial dance.
Around 100 million years ago, an asteroid 10 kilometers across is ejected from the asteroid belt. Dislodged from its orbit by Jupiter, it is now on a collision course with Earth. When it strikes, the impact generates a fireball so hot, anything within a 1,000 kilometer radius dies instantly. The impact throws some 300 billion tons of sulfur up into the atmosphere. And during the nuclear winter that follows, 75% of species, plant and animal, are wiped from the face of the Earth, including the largest creatures ever to walk on its surface. By driving the dinosaurs to extinction, Jupiter cleared the way for us to inherit the Earth. And although it still occasionally flings asteroids our way, Jupiter also protects us. For objects heading toward Earth from the far reaches of the solar system, the giant planet's immense gravity acts as a shield. Around 100 years ago, a lump of rock and ice 4 kilometers across is hurtling towards the inner solar system. But Jupiter stands in its way.
5, 4, 3, 2, 1. We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
70 years later, a mission launches that will witness just how effective a shield Jupiter can be. On board the Space Shuttle Atlantis, the Galileo orbiter. Three years after Galileo launches, comet Shoemaker-Levy 9 has been captured by Jupiter's gravity. And now, locked in the giant planet's deadly embrace, tidal forces begin to tear the comet apart. Its journey into the inner solar system cut short. What happens next presents the Galileo scientists with a unique opportunity.
And so everyone was observing it, and they realized two things. One is that it had just passed very close to Jupiter and probably had gotten pulled apart by Jupiter's tides. And the other was that it was going to crash into Jupiter 2 years later.
The discovery that a comet was about to hit Jupiter was a huge surprise and very exciting.
After crossing the inner solar system, Galileo is approaching the spot where it will witness the comet's final moments.
We knew Galileo would be able to see the flashes directly. We knew that the impacts were going to occur on the night side and that Galileo was going to be able to see them.
On July 16th, Galileo sees the first fragments of the comet enter Jupiter's southern hemisphere.
At 60 kilometers per second, the fragments really heated the atmosphere, red hot, almost to the temperatures of the sun.
And the pieces hit the planet one after the other.
Pieces of comet Shoemaker-Levy 9 strike Jupiter over the course of 6 days.
They looked like big flashes on Jupiter. The pictures of the impact were fantastic.
These tiny points of light, captured from 240 million kilometers away, are the only time a comet strike has ever been witnessed. The most destructive impact releases energy equivalent to 6 million megatons of TNT, leaving behind a giant dark cloud 12,000 kilometers across. By capturing objects in its orbit and incinerating them on impact, Jupiter protects us from bodies that might otherwise collide with Earth.